Hello student, welcome you once again. Now in this lecture we'll discuss about the Z transform from standard functions. Previously we have seen what is the Z transform. See once more time we will just revise that Z transform. Suppose if we have any sequence fx, so Z transform is nothing but summation k runs from 0 to infinity f of k z raised to minus k. Okay, so this is the definition of Z transform and we just call it as capital F of Z for a casual sequence. So if the k runs from minus infinity to infinity, we just vary this limit from minus infinity to infinity. That's it. This is the only change. Now suppose if we take the first function, so let us have this first function, unit impulse function. You may have seen this in Laplace transform. What is unit impulse function? Okay. So first of all, let us see this. What is unit impulse function? It is defined as delta k. This is what its value is 1 for k equal to 0 and its value is 0 for other values of k. Okay. So if we draw the function, okay. So if we draw the function for k less than 0. Okay, so for k equal to 0 value is 1 and for k is not equal to 0 the function is 0 everywhere here like this. Okay, so see now what is the Z transform of this? I'm not going to going in detail about this finding the Z transform, as it is very simple. So Z transform of this delta k means unit impulse function. So this is simply what, if we put this in the definition, Z transform this summation of minus infinity to infinity f of k is delta k into z raised to minus k. Okay, like this, because we don't have specify any value of k, whether it is from 0 to infinity or minus infinity to infinity. If it is not, we just take the as usual definition from minus infinity to infinity. Now if we see that function k equal to 0, the value is 1 and for other values of k the value is 0. Okay, so basically if we just vary this summation, it is dot 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 from minus infinity to delta of minus 2 z raised to minus of minus 2 is plus 2 plus delta of minus 1, I am just varying the sum, z raised to 1 plus delta of 0 z raised to 0 is there plus delta of 1 z raised to minus 1 plus up to so on up to infinity. Now if you observe, these all values are 0, this value is 0, this value is 0, oh, this value is 1. Am I right? So delta 0 is 1 as it is given. See, for k equal to 0 the value is 1, isn't it? So therefore this is 1, z raised to 0 is always 1, so this total value become 1 into 1 is equal to 1 and others values as it is 0. Okay, so therefore what is my z transform of this delta k? This is simply 1, isn't it? Okay, it is very simple. You just have to substitute the value of whatever delta k is given or whatever fk is given and just vary the sum, expand the sum. Okay, so let us see the second function. The second function I have, it is unit step function. Okay, so unit step function. So same as that of previous, you can easily find out the unit z transform of unit step function. So how it look like? U of k, it is given by, this function is like actually like this. It is 0 for k less than 0 and it is 1 for k greater than 0, greater than equal to 0. So if we just see the graph of this function, so for k greater than 0 the function is like this. This is the step function, unit step function, and for k less than 0 the value of function is the value of function is 0. So this is 1 and value of function is 0. This is for k greater than 0, greater than equal to 0. This is for k less than, strictly less than 0, like this. Okay, so how do I find this z transform of this function? It is simply what I'm just giving you directly the z transform. It is z transform of u of k unit impulse function, it is z upon z minus 1. You may use the definition. Okay, so see here the same thing. We just instead of this delta k, there is uk, and for k less than 0 all values are 0. For k greater than 0 all values are 1. Okay, it is simply, see, basically what happening here. So u of k is equal to, if we apply the definition for k minus infinity to plus infinity, u of k into z raised to minus k. So what happening, from we just come from far away, minus infinity and plus up to, suppose u of minus 2 into z raised to plus 2, it become plus 2. Okay, minus minus become plus, plus u of minus 1 z raised to plus 1, plus u of 0 z raised to minus 1, plus u of 1 z raised to minus 2, plus so on. Okay, and what is happening here, this becomes 0, this also becomes 0, but this is 1, this is also 1, isn't it? Okay, because see the function for k greater than 0 value of function is 1, for k less than 0 value of function is 0, and like this. Okay, and what happening, so this is equal to what, up to this point all values become 0. Okay, and what is here, 1 into z raised to minus 1 is 1 upon z. Okay, okay, sorry, z raised to 0 is there also, u of 0 z raised to 0, u of 1 z raised to minus 1, and so on. Okay, so z raised to minus z raised to 0 is 1 simply. Okay, plus z raised to, u of 1 is 1, z raised to minus 1 is 1 upon z, plus next is 1 upon z square, plus so on. Okay, so what I get, 1 plus 1 upon z plus 1 upon z square plus so on. Now this is nothing but your geometric progression, a plus ar plus ar square plus so on. What is this sum, a upon 1 minus r, we have seen. Okay, and if we expand this, what I get, a means 1, means 1 upon 1 minus r is, see what is here, so which is a geometric progression actually, with first term a is equal to 1 and common ratio r is 1 upon z, isn't it? So this is simply 1 upon 1 minus 1 upon z, and if we expand this, just take the cross multiplication in the denominator, you'll get z upon z minus 1, and that we have taken here, see this one, z transform of unit step function. Okay, unit impulse function, unit step function. So this may be, these two functions may be there in online exam or as a objectives. What are the z, what is the z transform of unit step function, what is the z transform of unit uh, impulse function? Okay, for unit impulse function it is 1, for unit step function it is z upon z minus 1, isn't it? Now come to the next, third function, it is very important. Suppose if my fk is a raised to k for k greater than equal to 0. Oh, here k is greater than 0, positive. Okay, so how do I find this? See, just apply the definition, z transform of fk is equal to summation. Now here k runs from 0 to infinity, casual sequence we have seen. Okay, fk into z raised to minus k, substitute z fk, so z raised to a, z of a raised to k, this is summation. What is happening, a raised to k z raised to minus k runs from 0 to infinity. Okay, now see, basically a summation. How I write this. So this is a into z raised to minus 1 raised to k, because we have a rule from exponent. It is a raised to m into b raised to m, a raised to a into b raised to m, like that. Okay, so this z raised to minus k can be written as z raised to minus 1 raised to k, because we have a raised to m raised to n is equal to a raised to mn. With the understanding of these rules, we just expand this sum, k runs from 0 to infinity. Now expand. what happened for k equal to 0? What I get? A into z raised to minus 1 raised to 0 plus for k equal to 1, a into z raised to minus 1 raised to 1. For k equal to 2, a into z raised to minus 1 raised to 2 plus so on. Isn't it? And what is this? This is again a geometric progression. So a into z raised to minus 1 raised to 0 is nothing but 1. Isn't it? This is a upon z raised to 1 plus a upon z raised to 2 plus a upon z raised to 3 plus so on, because z raised to minus 1 is 1 upon z, like this. Now see, again this is a geometric progression with a is equal to 1. First term is 1. Okay, first term is 1 and common ratio is 1 upon z. Sorry, a upon z, not 1 upon z. Isn't it? So the sum is a upon 1 minus r. So this is equal to a is 1 divided by 1 minus r is a upon z. Okay, and if we solve this, what I get? Z divided by z minus a, and this is the z transform of a raised to k. And obviously your mod z is greater than mod a. Isn't it? Okay, fine. Very good. This is the z transform of a raised to k. Okay, so but what is the z transform for the function fk? Similarly, for fk a raised to k, but the picture is different here. See, k is less than 0. Oh my god, what is happening here? K is less than 0. Okay, so how do I get this? So this is simply what? There is a slight change. What is z transform of this a raised to k? This is z divided by a minus z. This is the only change. See here, z minus a, here a minus z. Okay, and of course this is mod z is less than mod a. This is the difference. See, the condition is also changed. Okay, so this is about the z transform of this a raised to k for k less than 0. And what is happening for this third function? Okay, whatever that result. Okay, I'm not, I have forget the number. Okay, so fifth maybe, for suppose if fk is equal to a raised to mod of k. What is this? For all k belongs to my integer set. See, this result is actually the combination of above two results, for less than and for greater than. Okay, so therefore z transform of this a raised to mod k is basically az upon 1 minus az plus z upon z minus a. Okay, so where mod a is less than mod z is less than upon mod a. Work on this, and so just try to find how do I get this. Okay, about two results. So you may use the definition, just simply apply, expand the sum, and use the geometric formula, sum of geometric terms here. Okay, now so next result 6 1. What is that? Suppose if my fk is equal to, this is same as that of previous, e raised to ak for k greater than equal to 0 for casual sequence. Okay, so this is simply what? Z transform of e raised to ak. Again use the definition and expand this. It is z upon simply z minus e raised to a, where mod z is greater than e raised to a. Instead of a, there is e raised to a, because see what, how I write this e raised to ak. This can be written as e raised to a raised to k, and this e raised to a is nothing but a raised to k, like this. And I just apply this result here. I have replaced this a by e raised to a here only in the above result. Okay, so that is simple, no doubt in that. Now let us come to the next. This is very important. Okay, so what happen if my fk is like this? See, fk is sine of ak for k greater than equal to 0, trigonometric function. Okay, see, just apply the definition. Z transform of this sine of ak is equal to Z transform of, so we have the formula actually. What is that formula? Sine of theta is equal to, what is that? E raised to I theta plus, sorry, minus e raised to minus I theta upon 2I. This result you may have seen. I am just using this result here. Okay. So sine AK is nothing but e raised to I AK. Theta is AK minus e raised to minus I AK divided by 2I. Separate the terms because we know that Z transform of e raised to AK. Okay. That's why. So this is 1 upon 2I into Z transform of, this is e raised to I AK minus Z transform of e raised to minus I AK. Apply the previous result to find out the Z transforms. Okay, so this is 1 upon 2I, not 2 factorial, sorry for this. I have made a mistake here. So this is 2I, 2I. Okay. Now what is this? Z transform of this e raised to I AK. With the help of this previous rule, Z upon Z minus e raised to I A. Z upon Z minus e raised to I A minus Z upon Z minus e raised to minus I A. Okay, like this. Now just take the cross multiplication. After doing the cross multiplication, what I get, it is Z into Z minus e raised to I A minus Z into Z minus e raised to I A divided by, there is a product of these two, Z minus e raised to I A into Z minus e raised to minus I A, isn't it? Now if you solve this, what I get, this is equal to, this is equal to what? The Z square is there, Z into Z is Z square minus Z into minus IA. Okay, and then here it is minus Z square, so minus Z square plus Z square get cancelled. Okay, Z is common, 1 upon 2I is there, Z is common, inside the bracket I'll get e raised to IA minus e raised to minus IA. This is inside the bracket. So this is of course Z. See, this minus plus Z square minus Z square get cancelled. And from these two I'll take Z common. Okay. Divide by. So if we expand this sum, what I get? Z square minus e raised to IA minus e raised to, sorry, plus, not minus, IA plus Z into e raised to IA, like this. It is Z common, and here if we just take e raised to IA into e raised to minus IA, like this. E raised to IA, e raised to minus IA, it become 1. Okay, so 1 upon 2I is there. Now, so if we just bring this 2I into the numerator, so what happened, it is Z into e raised to IA minus e raised to minus IA divided by 2I. Okay, I just bring this 2I here upon Z square minus e raised to IA plus e raised to minus IA. Oh my god, this is somewhat uh, lengthy. Okay, so this is just a calculation part. Okay, I'm not doing the different thing. Okay, now what is that? See here, e raised to IA, we have the result cos theta plus I sin theta, cos e raised to I theta minus e raised to minus I theta upon 2I is equal to sin theta. Okay, and if, what if we take plus here? Okay, so what is the result for cos theta is what? Simply e raised to I theta plus e raised to minus I theta divided by 2. There is no I in the denominator. Okay, so what happened, this is 2 cos theta is equal to e raised to I theta plus e raised to minus I theta. Why I'm taking this term? Because that I'm using here. Okay, and here this is nothing but simply theta is a, so therefore z into sine of a divided by z square minus cos of a, 2 cos of a, simply 2 cos of a into z plus 1. This is a z transform of sine of ak, and the condition is also mod z is greater than 1. Okay, so similarly, what if my fk is cos of ak? So there is slight difference in the numerator only, z into z minus cos a divide by z square minus 2 cos az plus 1. Again mod z is greater than 1. Okay, so this is my 8 result. Now next, the similar kind of result is there, z transform of sine hyperbolic ak. What is that? Only replace sine by sine hyperbolic and cos by cos hyperbolic. You may get the result z into sine of hyperbolic a divided by z square minus 2z. I'll just take a front cos hyperbolic a plus 1. Now the condition is different here. Of course, this is for k greater than equal to 0. Your mod z is greater than maximum of this mod of e raised to a, mod of e raised to minus a. This is the condition. And for the last z cos of hyperbolic ak, this is z into z minus cos hyperbolic a. Again the denominator is same, z square minus 2z cos hyperbolic a plus 1, and the condition is same. For this is of course for k greater than equal to 0, your mod z is greater than your maximum of mod e raised to a, mod e raised to minus a. Okay, so these are the basic results that are useful. They may be there in the objectives, okay, exam, and just you need to focus on them, you need to just understand. And those I have left, just try to find out the z transform of that. Here are some another rules. Z transform of nck, it is bracket z plus 1 divided by z raised to n, and so on. You just need to just focus on this also. Okay, so hope you have got this. In the next video, we'll just come with the properties of a z transform.